It is quest physics students. We are going to determine the specific heat of the material by using a calorimeter students. First of all, we have to understand what is the calorimeter is. Calorimeter is a vessel students which is made of copper, and the outer surface of the vessel is polished smoothly to avoid the radiation of the heat students. And it consists of a lid also students. If it is the shape of the calorimeter, okay, it is provided with the lid students. The lid is having two holes students, okay, to keep the thermometer, okay students, to keep a thermometer, and a stirrer in. It is the stirrer students. It is the stirrer, and here it is the thermometer. And it is made of copper students. And actually what goes on, this calorimeter is kept in a wooden box which is filled with the wool or the rag students. It is the shape of the calorimeter students. The purpose is we fill some water in and we drop the material whose specific heat has to be formed, and we have to stir it, vigorously. With that, what could happen? The temperature will be equal in in the water and as well as the material which is dropped in. Actually, what goes on, students? The experiment, to determine the experiment, we have to know the apparatus what we are using. It is the calorimeter, students. Then after, what we have to do, we have to heat up the material whose specific heat has to be determined. That material has to be taken in the form of small bullets or the lead shot, students. You can take the lead shots. Means what? We are finding the specific heat of the lead shots. The apparatus heats the material whose specific heat has to be determined should be heated in a container, students. This container just looks like this. Okay, students. And in this one, another container is fixed like this. It has the connectivity in this way, students. Okay, students. Here in this one, we have to fill the water, and it works like the water bath, students. We have one more tube in this one, students. The tube will be like this. Here, it has a provision to move it up and down, students. We can lift it up and down. Then we have to keep the shots whose specific heat has to be determined. Keep it on the up of this water bath, and we have to heat it, students. On heating, the water get heat up and the vapor which is produced here make this material to get heated. It has a provision also to measure the temperature of this lead shot, students. Here maybe a inlet is like this, through which we have to keep a thermometer in, okay, and we have to measure the temperature. It is the arrangement, students. Then we have to lift it up, and these lead shots moves through this, and they fall into this container which has the water in, students. It is the basic setup to determine the specific heat of the material, students. And how the experiment will take place, we will understand how we have to do the experiment. First, we have to measure the weight, or you can say mass, of the calorimeter. First, we have to measure the mass of the calorimeter. That too, the empty calorimeter. I am writing stepwise here. Mass of empty calorimeter as M1. Okay, students. Its initial temperature. We have to record the initial temperature as T1 degree centigrade, students. Then after, in the calorimeter, we have to fill 1/3 of the water in. Okay, students. Then we have to measure the mass of the calorimeter with the water, students. Mass of the calorimeter with the water. Mass of calorimeter plus water. Measure it as M2, students. With this we will get mass of the water. Mass of the water is equal to M2 minus M1, students. Mass of the water is M2 minus M1. See this? Mass of the empty calorimeter is M1. Its initial temperature is T1 degree centigrade. Mass of the calorimeter plus water is equal to M2. With this, if you subtract this one from this, we will get the mass of the water in calorimeter. Initial temperature of water is equal to T1 degree centigrade only, students. Both are at same temperature. That's why we are taking T1 degree centigrade is both for the water and calorimeter, students. Then after remaining we have to do what I said. After doing this experiment, we have to transfer the lead shots into the calorimeter. Then after we have to stir it well. Then we have to find out, okay, students, the mass of the calorimeter added with the lead shots. Before that, when it is in water bath, we have to measure the temperature of the lead shots. That is what I am writing. Temperature is equal to T2 degree centigrade, students. Then we have to drop these lead shots into the calorimeter which has the water in, students. Then again we have to measure the mass of calorimeter plus water plus shots as M3, students. Okay, students, then we can find out mass of lead shots whose specific heat has to be determined is equal to, okay student, M3 minus M2. See this, mass of calorimeter plus water is equal to M2, and the mass of the lead shots is equal to M3 minus M2. Okay students, and final temperature we have to measure when you drop the lead shots in the calorimeter, and you have to stir it well. Then finally we will get a temperature. Temperature of the water increases and the temperature of the lead shot will decrease, students. Temperature of water plus calorimeter is equal to, after adding the lead shots in, what you get, students? Means final temperature of calorimeter plus water is equal to T3 minus T1. What is the T3 here? When we added and we stir well the lead shots in, and the system temperature fall into T3, and initially they have the temperature of T1. In the same way, we have to find out it is the final temperature of lead shots is equal to T2 minus T3, students. T2 minus, okay, mass of the lead shots we have. And what is the principle of the calorimetry, students? The principle of the calorimetry is heat lost is equal to heat gain. Heat lost is equal to heat gained. Who lost the heat here, students? Lead shots lost the heat. According to the equation, Q is equal to MST. Okay, students? For heat lost, who lost the heat? Lead shots. We are writing it as the Q1. Mass of the lead shots. You know that mass of the lead shots is equal to M3 minus M2. And specific heat of the lead shots, we have to find this. I'm calling it as the SL. And temperature of the lead shots, see this? It is T2 minus T3. Okay, students. Similarly, it is the heat lost. These are heat lost. And we have to find out the heat gain. Who are gaining the heat? The calorimeter plus water. Heat gain. Who are gaining? Calorimeter and water. What is the mass of the calorimeter? M1. Let's say the specific heat of the calorimeter, I'm calling it as a SC because it is made of copper. And temperature, okay, final temperature of the calorimeter plus water. How much it is? T3 minus T1 plus, it is about the calorimeter and water we have to take. What is the mass of the water? M2 minus M1 into specific heat of the water and final temperature of water, T3 minus T1. Okay, students, according to the equation, you have learned that heat lost is equal to heat gain. Heat lost, we call it as the gain is equal to Q2. We have to show Q1 is equal to Q2. Then Q1 is equal to what? M3 minus M2 into specific heat of the lead shots into temperature difference, T2 minus T3 might be equal to this one, M1 into specific heat of calorimeter into temperature difference plus M2 minus M1 into specific heat of water into T3 minus T1. Further, we can write it as M3 minus M2 multiplied with the specific heat and change in temperature. Here in this, T3 minus T1 is common, students, is equal to T3 minus T1 of M1 SC plus M2 minus M1. And finally, the specific heat of the material is equal to T3 minus T1 of M1 SC plus M2 minus M1 upon M3 minus M2 of T2 minus T3. It is the desired equation, students. By using this relation, you can find out the specific heat, students. In this way, we can determine the specific heat of the material by using a calorimeter, students. If you like the video, please forward my video and don't forget to subscribe my channel, students.